Hello everyone, welcome to this session where we are going to have several hands-on coding exercises in Python across linear search, binary search and hashing. Before we start with some of these coding exercises, just to set up some context about this, uh, you are likely to get similar question in your board exam where you might be given some numeric or alphanumeric uh, set of uh, list, and then you may be asked to sort it out, basically to sort it, and then answer number of comparison or other things using binary search versus doing it without sorting on linear search. And around binary search, there could be several variations around the search algorithm itself, which can help you either answer much faster or avoid lot of computation in certain tricky scenarios. So let us get started with this. Let us have a quiz because we are talking about several, uh, search algos, and you might have seen, someone is having worst case ON versus O log n, and you might be, thinking that how much difference does it make? So let us take actually one exercise where you can see how much difference it can make if you really use linear search versus binary search on a very, very large data set. So say that your database is having almost 2 raised to the power 30 records, right? If you read these big numbers, it could almost be like 107 crore, right? As you know, if you do a linear search, right? But before we get into that, why don't you pause this video here and assuming that you have almost 100 crore plus, uh, you know, uh, that size of your database. If you have to use linear search, how many comparison? And if you have to do binary search, how many comparison? And see if you are having some aha effect, where you can say that, wow, one of these is definitely better or whatever. So pause and see you soon. Okay, so hope you have looked at it, and let us see this in perspective. In linear search, what is happening? Every time, every pass, you do n minus 1 comparison. Then the second pass you do n minus 2, then n minus 3, dot 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 till one comparison towards the end. So in every loop, basically how many comparison you are going to do? N plus n minus 1 plus n minus 2 dot dot dot. Or on average, if you see, this will translate into almost n by 2, right? Number of comparison. So for 100 crore records, 107 crore records, you might end up doing almost 5.4 crore kind of 5.35 crore kind of comparison. That's a huge number. Imagine actually, comparing 5.3 crore operation on a small PC, right? Then, if you do, binary search, so what it will be log n, and what is n here? 2 raised to the power 30. Assuming that we are talking about, a log base 2, 2 raised to the power 30 will be what? Log 2 raised to the power 30 will be just 30 comparison. So even if you have 100 crore records, and as long as it is sorted, you can just find it out in approximately 30 companies. So 30 comparison versus 5 crore. So that will give you some idea why different set of search and even sorting algorithm exist, and why you need to be very, very careful, to pick one over the other. In case if you are thinking that where you need 100 crore, think about the use case. It is all around. Look at your Aadhaar, right? Almost we are like 150 crore approaching. Sure, for sure 140 crore. So 140 crore Aadhaar is somewhere stored, right? And when authentication queries go for it, Aadhaar authority has to answer that almost in real time. Just assume that based on Aadhaar, if they have to do a linear search, so 140 crore or 70 crore operation to find, where your record is, right? So, yes. With this in mind, let us try and look at, one typical standard question as per your syllabus, right? So this is about doing linear search, sorting, and binary search on a list of numbers. So our input numbers are 50, 31, 21, 28, 72, 41, that till 9, right? And what it is saying is, if you do a linear search, right, and say you have to search for 1, 5, 55, 99, then number of comparisons required, right? And then it is saying that if you sort it using a Python sort function, and then if you search for the same using binary search, then how many number of comparison will be needed. So let us get started with this. What you can do is, after reading this question, you can pause this video, try and code it out yourself, and then come and let us see how it goes, right? So see, your numbers are this, right? And okay, this is your number. Now let us define our linear search, right? This will also reinforce the code that you saw in your PPT. So what you are going to pass here, you are going to have an array, and you are going to have the key that you want to do, right? And then you say that for I in range, length of array, right? What you are going to do, if array of I, right, is equal to key, right, you are going to say that return your ith elements, and this is also asking for number of iterations. So let us start with a variable around iterations and initialize it to 0. So if this number is equal to this, anyway, when you are coming here, your iteration, right, will increase by 1. So if this number is equal to key, then what we are going to do, we are going to simply return I with number of iterations that we have, right? And if you don't find it till end of the loop, you actually return from here, and what you return, that item is not found and number of iterations, right? Now say that number to be searched, right? So number to be search or key list, right? Your key list, it is saying is 1, 5, 55. 1, 5. Is it 1, 5, 55, 99? Okay. 55, 99. Right? Okay. So let us have it here. Then let us declare our function and then say that for let us say let's do it, right? So for item in key list, right? What we are going to do, index and iterations, right? So our index and iterations are going to be your linear search, right? and where you are going to do, it on array and with this item, right? Then you can actually print. So you can check if your index is not equal to -1, right? So then you can say that print, right, items uh, key, uh, you know, uh, then you are having your key as key, right? Uh, then you are having found, right? And you can have here at which location, uh, iteration. So you can say after you know, these many iterations. Okay, let us simplify it. And if it is not found, then what you say? You say that key is not found, right? So very important to start writing code, right? Key not found. Uh, okay, after the many iterations. Let's see what happens. We are getting linear search. Linear search, okay. We have in coding, we always realize array is not defined. Let's call it array, right? This is needed. Then key is not defined. Yeah, key is not defined because yeah, we can make it key worry, right? So 1 is not found, 5 is not found. Approximately in each of these cases, whenever not found, there are so many 1, 5, 55, 99. Okay. Now let us say that we want to sort it, right? So if you do array and you are actually going to sort it, then you can actually print your array items, right? So now this is sorted. So with this, let us define our binary search where we are going to give an input and a key to be found, right? Let us define in the beginning itself our iterations as 0, low, high as 0, and then length of array -1, right? Now set up our loop. It is while low is less than equal to high. What we have to do? We have to find our mid, right? So our mid is going to be low plus high, right? And then divided by 2. We'll show a variation of it. But anyway, if array of mid, right? If array of mid is equal to, right? If this array of mid is equal to what? Key, right? In that case, you return from here. What you return? You return mid, right? Which position is found, and then you return iterations. Since you are returning iterations from here, inside the loop, first thing that you should do is iterations plus equal to 1, right? So you are actually doing this. Now the scenario is else if your this mid element itself is less than your key, then what you are going to do? your low is going to be mid plus 1, right? And you can actually even have it, right? Or yeah, it should actually work, right? If else, else we are going to say your high to be mid minus 1, right? And if you reach at the end of the, you return minus 1, and then you return iterations, right? Let us see how many bug and other things we have, at least this so, and then we can actually uh, sort it out, right? So if you sort it out, uh, linear search will remain the same. Binary search, if you have to find it in 4 operations, right? And then it is also asking you to test for on 555 and 99, right? Uh, and then you can say key not found, just 4 comparison versus 24 comparison, right? While you actually go ahead from here, you'll see that there are overflows, so your low high itself could be quite so the way people do is, from low they define it. Sometime when you actually approach, right, some high level interviews, so this line, if you keep in mind, right, because here what you are doing, earlier you were actually adding low plus high, and that could be a bigger number with potential of overflowing. But if you do high minus low, you are actually taking a number, and so your mid is always going to be this. Even this code will work exactly the same way, right? So if you see here again the 4 operations, right? But this can give you some brownie point if you develop coding skill like this. Okay. Now actually it is saying about some unsorted word, right? And so these are your unsorted word, right? Uh, Let us say it is word array, right? Um, okay. So read through this question. You can yeah, just read through this question. It is very similar to what I'll just stop it for one moment. Just read through this. Okay. So will actually be, I have uh, I have just copied it for you. So I think all our codes should work as it is, right? So you can actually simply call it on our right, control A, control C. So you can simply look at your linear search, right? And key list here, right? So but key list we have to determine, right? So key list, whatever they are asking, let us call it word list, right? So what all they want to check you, right? Um, Amazing, perfect, great, and uh, wondrous, right? So amazing, Hmm. You simply use it, right? And we can actually keep it our word list here, right? Okay. So when we are looking into this, we have to actually pass our words, right? And then we can say key here, right? And you can find out what is happening. Word list is not defined. Okay, let's define it. So all the some found, some not found, right? Unless they're in beginning, almost like very linear. And then what we have to do? Then we have to sort of search our uh, word, right? Sort. So we are calling inbuilt, Python sort, and then you can print, right? So you can print words. So now it is actually kind of in same order. If you actually now try and call binary search on this, right? The same code. I'm gonna take this one, right? Take this one. Control C. So you can actually see here binary search. So most of the items are found within 4 to 5 iterations, right? And you can do the command. So with this, we have looked at a couple of variation around binary search. There are some other questions that you can actually kind of try. Um, and what I should advise you at this stage. We practice a lot of binary search related things, right? That's why that you could be expected in an exam, and also learn some of those theory kind of things, number of swap and other things that we discuss for sorting, and which usage it is found for searching. Thank you guys, thanks for joining this. um, Now we will be solving some more previous year question paper around Python SQL. So do subscribe and like my channel, and comment with your specific request that I have. In some time, I am also going to publish, sort of 5 model paper with model answers. Not only for your theory. Not sure how many of you are done with your practicals or what the schedules are, but even if I'm planning to kind of publish set of modules which can be customized based on minor changes here and there. So you know um, do look for hope to see you guys again soon, and we'll do more hands-on exercises primarily around SQL, Python, and some of the data structures that we are talking about. Thanks.